Hey, hello everyone. Welcome to another short video where I'm exploring stuff within Nuke. I know it's been a while since the last one, and I also know that some of you asked something, in the comments on YouTube. I saw some question that I completely forgot to reply, so I'm sorry about that. I'll try to be more consistent, and if anyone is asking something, I'll try to be responsive. Um, it's like I'm not very, I'm not into social media stuff that much, so I'm not like following even the video that I released. I'm not like checking comments, and I just recently noticed that someone asked something, and I just completely neglected to respond. So yeah, sorry about that. But anyway, we are here in this short video where I thought to explore something. I have made some backdrop with some yeah, it's like experiments, I guess. Not really groundbreaking solution, but something I would like to share. And so I thought, why not? So the first thing, it all started with this problem. I wanted to show you where it started. So it all started with this problem. Um, I'm working on a show where we are comping a lot of volumetric lights, and the client didn't like the shape of this light beam that came from the lighting department. They wanted it to be more diffuse because this is supposed to be some like fog layer. So they want the light, like the light beam to not be so straight and be more diffuse again. And we got an update from lighting, to be honest. So this like fixing comp is not really required anymore. But I thought to like show, if you're encountering like a similar issue, I thought to maybe show a potential approach. So it all started with our render of the light beam that we want to fix, or we want to change the look, and this is the different the fix. It's basically just blurring everything, but yeah, it started from this one, and all I did was with the lumina keyer or keyer, just isolate this should be connected there. There we go. Just to isolate the core of our light. So not the diffuse part, but more like the center of our light. And with the from, like that, so this is our render. So here we have a from. I'm basically subtracting my core from the beam, and I'm not subtracting it entirely, and we're gonna see why in a second. But all of that is just to isolate, let's say, the diffuse part. I want to blur. That's exactly what I did. So here I have like an eye blur node. That, by the way, it was released by Moritz Heike. I worked with him. It was the head of 2D at Scanline. So it's like super clever guy. And he released this eye blur that is basically, blurring or defocusing your image using a mask, but it has a much different effect rather than a traditional blur. So you can open the group and see how it works inside. So if I show you if we try to create a blur with the similar value, so I created the traditional blur and I set it to 150.5, and we compare the result. I'm even using the same mask, and we're gonna see what this mask is doing, but you see that we get a much different result. Okay, it's just the mask is basically isolating where the blur is happening, so we get like a double exposure. We see part of the original render and part of the blurred render, where here we can control the shape of our blur pretty much, right? So this roto is controlling how much we want to diffuse our cone, okay, or if you want where the diffusion is happening, is starting. So I can make it happen later in the light beam or earlier. By moving this mask, I can control that, and I can control the amount of diffusion by increasing or reducing my blur. Okay, and then I also added, but if we blur something, we tend to lose exposure because we are basically averaging values. So I had this grade where I'm controlling the amount of exposure of like the diffuse part of the cone light. And you can change the color if you want. So you can basically split the control between the like hot core and the diffuse portion of the light beam. And on the other side, let's turn off all of that. We have our core, and if we blend it as it is with the plus operation, let me clear here. We're basically blending the two together, but you can see that there is now that we are blending this hot core on a much more blurred light cone, we see some darkening around the edges. So in here, I'm basically soft diffusing the hot core so the blend is a little bit more natural. Okay, and these are basically just blur node with a mix. So it's not like blurring entirely; it's like mixing and softening the element. And I did it a bunch of times, just till it was working pretty much. And then I'm using a glow exponential, or you can use whatever glow node you like, to just control the how hot is the core. So basically, can control this. I can reduce the size, make it really popping, and then I plus it on top of that, and that's pretty much it. So that's a potential approach to fix that problem. So here we have, like the original one, and here we have the diffuse one, and probably right now it's a bit too hot, so we can, reduce the intensity, or you can just plug a grade like here, and remember to unpromote by the alpha, because we already pre-multiplied there, and now I can, tone down the exposure, and you can control how much intense it is before applying the other nodes. So this was the beginning, and again, not really, nothing groundbreaking again, but it's a way you can split the control of your light element and managing, separately the diffuse part, the core part, and combine them together to control them separately. And it's exactly here where I started to say, okay, what can I do if I need to recreate like a light cone or a light beam? Which node should I use in Nuke if I want to recreate it from scratch, right? So the first thing that came to my mind was obviously the Godrays node. We all know the old trick of creating a roto, and then we create like a shape. The roto is exporting in RGBA, and then we plug a Godrays like that, right? And we place the center here, and then if we start to translate, we're basically creating this sort of light cone, right? And we can do a lot of stuff. We can increase these steps, we can scale this up, right? And then we can do other things. We can start to rotate, we can do like a lot of stuff with this specific node. But I also discovered another node that I probably never used. That's the Glint node. Okay, so it's very similar to the Godrays. Okay, it has less control, to be fair, but we can do like very nice thing with this. Let me clear everything aside from the Glint. So overall, we don't have the translate and center. We just have the number of rays that we want to create. In this case, it's 2. So if I start to increase the length, I'm getting 2 rays. Okay. And I can increase this, so I can make it as many as I want. The interesting part is that I can go lower than 2 and having just one single ray, and I can control the rotation, right? Okay, and I can control the odd ray length if I have an odd number here. Like in this case, it doesn't matter that much. And that's pretty much what I can do with this. And you may think, okay, well, that's not really interesting in itself, right? But I, thought, okay, let's play around a little bit with this. Even the Godrays actually can give you some interesting result. Like if you, for instance, instead of using this, right, you just create a noise, and you start to break up a little bit the texture of the emitter. Let's call this the hot part, the emitter of your light. So you can create a noise, and then you can multiply this with your shape. So we're basically, or you can stencil it, or just to have a more texture inside. It's not plain white; it has some texture. Now we can control the scale of our noise, and make it more detailed or less detailed. And now inside the Godrays, we start to see some light beams, right? But we can also, play around with rotation and start to create very nice shape. Again, maybe it's not nice for you, it's dull, but I mean, I thought, okay, that's not bad. That seems to be quite cool. I can even gain this up, and you can literally create some, cool stuff just by playing with this thing, and you can add some color, like if I'm multiplying this noise, but I can grab the color wheel, for instance, and with this color wheel, I can multiply this with my noise. Okay, like something like that, and then maybe scale this wheel a little bit. Yeah, we need to take a look, keep an eye on our bounding box, because the Godrays, anything that is basically stretching pixel, in different direction, it allows you to curve and bend and translate. It's making your bounding box huge. So if we go into Godrays now and we start to translate this, you see that we are already, expanding our bounding box quite heavily. So it's better to crop immediately. But yeah, now I'm basically, having some color in my element, and I can maybe let's close this. I can bring my color wheel closer, so I have more of the color that I want, something like that, right? And so there you go. Now you start having some more interesting shape. And by controlling the noise, the size of the noise that we are basically applying to our emitter, you control how many light beams you see. So we can have more or less. And again, inside our Godrays node, we can do stuff. We can skew them, we can scale them up and create some very, I keep saying nice because I don't know exactly how to speak English, but interesting, probably that's the word. And you can animate your noise, you can animate your noise to give life to these whirly shapes, and you can translate your noise. You have all the control inside, your noise to generate animated image or images that resemble, like space stuff with some light in the center, And then if we add a glow, let me grab this one here. If we add a glow on top of everything, it's making probably everything a little bit more nicer. Maybe, yeah. Or maybe not, just playing around with stuff. So, you know, it sparkled some creative ideas just by playing around with this node. But again, I also thought, like, is there anything similar to the Godrays node? And I thought about the Glint node. Well, not I thought, I stumbled upon the Glint node. And I was able, using this node here, to create some interesting thing, like this very simple like meteor shot. Okay, it's meteor-like. You know, it's not like photorealistic. It's definitely not like an axiom or you know, simulation. It's not that detailed as a real simulation you can do in Houdini or anything like that. But it has some potential, I think. Like, I think that if you play around with this stuff in you know, like freely, it might give you some ideas that otherwise would be hard to get in Nuke. And it's nice. I mean, I like it. I like the colors. I like the fact that it, you know, it leaves a very nice trails, and you can play around with it. You have full control. You can extend the trail, give motion. Like here, you see I use some noise on an STMAP, and I gave some wobbly motion to the trail. You know, you can do stuff very, I mean, I keep repeating nice too much. Very cool, just by playing with simple nodes. So let's start like analyzing how I did this. And also I discovered another interesting, or another thing, not interesting, not cool, just another thing. You can use HTML in your like label, backdrop, or stuff like that. So if you like type here something like this, like header 1, you see that it's bigger, but then you can also apply some style. So I can say header 1 style, the property that I want to control is the color, and I want this to be cyan, for instance, and it gives color to whatever you're typing. Is it useful? Probably not, but it's cool to know, I guess. Anyway, so the beginning of this process started exactly the same as the task that we did before with the Godrays node. So basically, I have from this side my color wheel that is pretty much giving color. Here I have my noise and the grade to control the exposure. I'm multiplying the two together. Okay, and then I basically choose a smaller portion. Okay, it's not very well structured. There's probably a better way to get to this point. So I do it as you like. This is the way I did it without thinking. So I'm basically doing a roto, you know, plain roto. I'm using a fractal blur to distort it a little bit. You can use an eye distort and noise to achieve pretty much the same thing. And then I multiply everything with the color. Okay, and that's it. That's my source. So the color that we see in the final are coming from here. Okay, so this color here are basically the color that we get in here. And then I use the transform node to animate my, you know, to animate the emitter. Okay, so this transform is just some keyframe to animate the emitter. The only interesting thing is that we can see it here. If we go into our glint, okay, in our previous example, and let's say that I apply a transform in here, if I rotate my emitter, you see that the rays are not really rotating in the right direction. Okay, they keep staying horizontal. Okay, because the rotate it's set here. Sorry, not in the transform, but in the glint. If I open up the glint and I go into the rotation, now I can reorient my beam, my trail. So in here, what I did was basically creating a simple expression that linked the rotate of my transform to the rotate of the glint, and I just multiplied by -1, just to go in the opposite direction. So whenever my emitter rotates in a certain direction, like say the trail is rotating in the opposite direction. So it stays behind the emitter. Okay, so that's, you know, I just did that, and there you go. That's it. You know, now you have some like some trail following your shape, and then it's a matter of you know, managing the bounding box, adding some glow to make it pop. And in here, what I did was adding some distortion, you know, I'm using a noise to distort an STMAP, and then I'm dissolving between the original STMAP and the distorted one with this roto here. And this roto it doesn't make any sense now, so let me maybe make it a little bit more. So, you know, if I start doing something like that, you start to see that there is some distortion happening, and I can control the amount of distortion by changing the size of this noise. So if I want, you know, to see more wobbling elements going on in the trail, I can just reduce the size of my noise, and animate. You know, I can animate my noise, and you should see some motion going on in the trail. But I mean, you can play around with this if you want. But that's the basic of this setup. And I did exactly the same thing on another one with different color. I combined them together, and there you go. Now it's sucking badly. Maybe let's turn off entirely this STMAP. I prefer this. And then some stars. There should be some star there, and that's it. You know, similar approach, different result. You can see it here. Once again, it's not really a very photorealistic simulation of fire, but yet, you know, if you need to add a flame to a candle, very tiny flame, I think you might get away with this. So I'm gonna show you, you know, some motion in a second. So you know, you have some very nice wavy motion going on, and very similar approach. You know, STMAP, distortion on an STMAP, and an STMAP there to apply the distortion to your image. We're gonna see in a second. But yeah, the principle is the same. We are using an emitter, as we did before, with the noise that create the basic pattern for this fire, and then we are using a glint to create the rays, you know, that in this case are the flame, and then we are adding an STMAP to distort the fire. So it's more like garlic now than fire. But yeah, let's see how it goes. Same thing. Noise, a roto shape. Then, as I told you before, I'm using this to distort my alpha. So I'm using a noise, and I copy the red in the forward U, the green in the forward V, and inside this I distort, I'm using the forward as a UV channel to distort the edges of my alpha. Okay, and then I use a blur to just blur everything. All right, and then what I did here, in this case, I pre-mulled my noise. I colorized my noise, okay, and I pre-mulled it to have a pre-multiplied image where the bright spot is fully opaque and the dark are actually transparent. And then I masked this texture. This is basically the texture of the fire. Okay, it's just a colorized noise with some animation on the evolution, right? Then I mask this with my mask that I created on the other side, and then another blur for good measure. Why not? Then a corner pin to make it flat. Okay, so it's basically the base of my fire. It's sitting on the ground, and then the glint. So the glint is doing exactly what it's supposed to do. It's basically one rays. If we increase this, it goes in both directions. Then, you know, it start to expand the amount of glint applied to the source. In this case, I want just one going upwards, and then you can play around with the length, the rotation if you want to rotate it. But in this case, it's fire, so it should go from the ground up, and then just the motion. So the motion, so the wavy motion that you saw before, is basically controlled. It basically started with this STMAP that you can create with an expression node. Okay, so if you create with an expression, it's like, I'm sure you all know this, but it's like x plus 0.5, and you're gonna divide this by the width of your composition. And this is basically, Nuke is automatically replacing this keyword with the width of your canvas, let's say. So it grabs this from the project setting. And then you do the same for y, all right? But instead of dividing by the width, you divide by the height, and you get the same thing. Okay? So you can create your STMAP using this expression. And this STMAP is then processed using some noise. So let's see this part here, because I'm basically distorting my STMAP with some noise. I can show you. You see, this texture is basically what is distorting the STMAP, and it's what gives the motion to our fire. So let's start from this part. I'm gonna use a normal noise. We're using noise quite a lot, and here I'm using a different approach. Like, I want to basically copy the red and green channel of this noise into my main pipe, into my STMAP. But if I'm doing something like that, it's working, but it's not really. It's copying the same data. Like red and green right now of this noise are exactly the same. You see, I'm switching between red and green, and I'm getting the same value. That's because it's a monochrome image. It has the same value across the 3 different color channels. So I'm gonna copy the same value both for X and Y, and that's not let's say that's not adding any extra information to my distortion. Okay, it's the same value in both directions. So what I did instead was to create another expression node, and I wanted to basically convolve this kernel on top of my noise to get this. Okay, so here it's the red portion of my noise, this is the green portion. You see that they have 2 different directions. Okay, this is the red, this is the green. So I'm basically feeding these for the iDistort to distort my original STMAP rather than this. Okay, this has the same value in red and green. This one doesn't. Has 2 different directionality in the 2 coordinates. Okay, so in other words, I'm providing a real difference in terms of the coordinates I want to distort my STMAP. Okay, so red as a certain direction, green as a different direction, and we are feeding them into my STMAP and using them to distort it. So the way I did this was by creating this kernel that I'm applying to my Convolve node, exactly the same thing that you're doing when you want to create some lens effect. You want to convolve like a lens kernel to create some defocusing or stuff like that. It's the same principle. So this expression has just these 2 value inside. So if you create an expression and you set this to Cx, it basically creates a gradient that goes from -1 to 1. So it creates a ramp that goes from -1 to 1 in both directions. So if I set this to Cy, it does the same. It basically creates a normal map, generating a ramp that goes from -1 to 1 in X and Y. So what you're really doing here with this kernel that goes exactly from -1 to 1 or approximate 1. And this convolve is actually creating normals for this image. Okay, we are faking normals using this kernel processed by this convolve node. We are faking normals for the texture, and we are feeding this normal into our main STMAP using this copy. So we are copying the red and the green into the forward U and forward V, and these two are then used by the iDistort to distort our fire. Okay, so if we go down here, we see that if I turn off this, we are losing that detail. Okay, and on the other side, I'm basically treating separately the same STMAP with a different noise. So this noise here is what it gives the the wavy movement to our flame. Okay, so I'm basically applying this noise and applying an iDistort the same way as I did on this side, and then I combine the two with the dissolve, where I can choose more of what I want to see. What more, if I want to have more wavy movement, or more of the distortion that come from this side, like that. Okay, and then I'm basically controlling where this is happening using this rotomask. Okay, if I use entirely this, you see that I'm basically distorting also the bottom. Okay, but I don't want that. I want more of the more of this distortion to happen in here, and less at the top. So the top of my flame is basically receiving more of this contribution, so more of this noise, whereas the bottom of my flame is receiving more of this contribution, okay, more of this distortion, right? And then combined together, we're getting this result, and as usual, a crop, or in this case a transform, to make it smaller so we don't see that it's fake, and a glow to make it popping more. I also use a grid warp to control more the shape of my flame. Okay, so I can literally control more how I want it to, the shape that I want it to follow. So if I want bigger at the bottom, or smaller or anything like that, I can do it inside this grid warp here. And that's pretty much it. So same principle, different effect. Now, another interesting thing that I started to play around a lot with this Godrays and Glint stuff, and there's also another cool thing that I wanted to show you before wrapping up this video that was supposed to be short, but it doesn't seem so short right now. So this is the idea. I have my Godrays, okay, and traditional Godrays, and all I did was using a roto paint, okay, to basically draw a single dot, okay, and then I plug this into a Godrays, and let's see the property of my Godrays here. So I'm basically controlling the amount of dots by controlling the amount of steps, okay, and by doing so, I thought, okay, this is basically creating an array of this element, meaning the single brush stroke that I created inside this roto paint is basically cloned by my Godrays, okay, by changing the number of steps. So I'm cloning this roto paint brush using the Godrays node, right? So I thought, okay, maybe we can apply a texture that is going to be cloned using the same principle, and we can use exactly the same principle that we saw before, the convolving a kernel, or let's say spreading an image across another one by using a convolve node. But in this case, instead of faking normals, we can basically copy this element like so. So right now we are basically using the Godrays as a cloner, and we can translate our element, and I mean, it has some limitation. If I start to, for instance, to scale this up, you see that the values start to change, the exposure values start to change. So it has some weirdness that still needs to be figured out. But nevertheless, I mean, it's interesting that we can basically use the Godrays to generate an array of particle or element that can then be used through a convolve node to replicate a certain kernel. So in this case, again, I have this color wheel plugged into the convolve node, okay, and on the other side I have my Godrays that is spreading these dots, and then I'm basically cloning the color wheel using the Godrays node. And inside the convolve, I just turn off the normalize. If I turn on the normalize, we are basically losing our elements. I mean, they're there, but the exposure is very low. So I turn off the normalize, and I'm controlling the exposure of my elements by plugging a grade after the Godrays. Okay, so I can make it pop or less. I mean, make it more intense or less intense by playing with this. And the interesting thing is that I can basically have this controller. So if I set it there and I go into my Godrays, let's scale this to 1 and let's translate here like so. Okay, can just doing like that, and now if I start to increase my step, I can get more of my element. And you see that when they are on top of each other, they're really not respecting the fact that this has a completely solid alpha. I guess that's part of how the convolve node works. So that's the problem. And if I check here, the alpha is extremely high. Okay, so we need to clamp our alpha for sure. In here, the alpha is 1 is correct, but after our convolve is start to behave weirdly. So let's clamp everything. All right, and then what we can do? Well, if we want to, clone a bunch of time this thing, we can just, transform and merge. So we can just do something like that, and can go down, and we have like this, and they are all controlled by my Godrays. So if I start to translate my Godrays, they're gonna behave in sync. Okay, and I don't know, I think it's worth to just mention, if you need to create an array of something, I don't know, lights in at a concert, you need to recreate an element and then apply glow and Godrays and whatever. It's quick to do like that instead of doing manually, I suppose, or it's quicker. But yeah, so that's another way of using a conjunction of Godrays. I mean, the Godrays not used to generate, light beams or stretching pixel as we usually do, but more like a particle generator or an array generator that can then be processed through a convolve node to multiply elements. Okay, that's the idea behind this. Lastly, I think there is something else here. I don't know, I played with this stuff during the weekend because I'm a boring man and I tend to stay home and play with Nuke. Yeah, my girlfriend is very happy. Oh, here I did this. I basically used the rotopaint. I'm just trying to figure out what I did because I don't remember. So I plus this over, and let's try to paint something. Oh, okay. I'm just distorting and applying some shadow automatically by using a rotopaint that now is. So I'm doing the same thing. I'm sorry. I'm just trying to figure out what I did because I forgot. I'm using this kernel and I'm convolving it on a paint stroke. Okay, so basically I'm creating normal maps for paint stroke, and then I'm plusing this on top of a traditional STMAP, okay, and then using this to distort an image. Okay, so that's nothing crazy. But now using a glint, again, we can now use a glint to generate some directional shadow, because even just paint stroke and glint together. I probably create. Oh no, what's that? No, please. Sorry. Let's create a glint. There you go. It gives you some nice thing. Like I can now extend this, put it one raise, and I can rotate this. So it gives you like some, I don't know, Richard Donner Superman intro, where we have all those letters flying toward the screen. That was, remind me. Well, hopefully or thankfully not so bad. They were better than this, but yeah. So you can create such stuff, and then where is the scale? Aspect ratio, length. There is no scale here. Oh no, because that's in the Godrays. So we need to create Godrays maybe, like so. And then if I scale this out, there you go. Now I can translate this and have that effect. Yeah. So anyway, in this case, we are using the glint to generate some shadow. So I'm basically plugging the glint directly to my rotopaint, extracting or removing the rotopaint just to get the shadow or the map that we're going to use as shadow. Then we grade them, we invert them, and we multiply them on top of everything. So we are basically giving shadow to this basic bad distortion. Okay. And I can control how much is distorted by playing with this plus, I think. Yeah, not very cool, but still interesting that you can apply the same principle to basically fake normal also for paint stroke and use them to distort your image. All right, I think that's it for now. Sorry it was supposed to be short. Sorry about that. But yeah, it took some time to go through all my playground, and I really hope that it might spark some interesting ideas in you. And I'm always curious to know how you're gonna use this stuff, if you're gonna ever use it. Probably not, but who knows? So feel free to reach out, and I will try to be more responsive if anyone will ask anything. All right? Thank you very much for your time and attention, and speak to you soon. Bye-bye.